Welcome back. So this is going to be probably a little bit faster video. I'm not going to be writing in it as much as I usually do because I've already made it, so this is a redo. Sorry about the last one having some issues, but let's start fresh. So brain dump, what do we know about solving equations? Well, the things that we know are SADMEP, which means PEMDAS backwards. We're going to subtract or add first, then divide or multiply, then do exponents or parentheses as needed. We also know we want to get x all alone by himself. And then finally, our goal is x equals some number or constant. That is our goal. That's why I have an exclamation point right there. All right. So next, what we have is, how do you create equations with variables on both sides and use them to solve problems? Well, we want to see when two equations or situations, that's what's cut off there, situations, would be the same. So that's going to be our key goal. At the end of both the video series, I want you to be able to tell me when two equations are the same. All right, let's do some key vocab. So first things first, we have like terms. So this is going to be same variable and same exponent, meaning 2x plus 3x or 2x squared plus 4x squared. But even constants can be like terms. 2 plus 3 is a like term because 2 plus 3 would give us 5. We can combine them. An important thing to note when solving equations is that you must combine like terms before you ever start moving over to the other side of the equals. So that's why it says combine like terms before SADMEP, because that's how we move to the other side. Another thing we talked about was the properties of equality. What we do, add, subtract, multiply, or divide to one side, we must do to the other. The golden rule of algebra. Okay. And then the solution to an equation. It's any value that makes an equation true. So sometimes you'll have one solution, sometimes none, sometimes multiple. It's any value or number that we can plug into that equation and it becomes true. So if our equation is 2x equals 4, 2 is our solution because it makes it true. All right, so now to introduce our new word, identity. So what do we know? Well, we know a bunch of things already. We know that this bar right here is a multiplicative inverse, or not inverse, identity. Multiplicative identity, meaning that any number in the world that you can think of, if we multiply by 1, it's going to be itself. So 4 times 1 is 4, 5 times 1 is 5. Any number, a times 1 is a. Okay, this next one is the additive identity. We know that any number in the world you can think of plus 0 is going to give you that same number. So 1 plus 0 is 1. 8 plus 0 is 8. Any number a plus 0 is a. We also know that in the real world, identity means unique or the same. But I bet you what you didn't know is identity has an equation meaning, a math meaning. It has a math definition. It is an equation that is true for all values of the variable. So any number you can think of to plug in for x, y, z, l, m, w, the variable, it's going to work. That means we have an identity equation. Alrighty. So the next thing that we're going to discuss is some math literature and vocabulary. But before we do that, we are going to do a vocab activity. So it says, how many solutions does an equation such as 5x equals 5x have if the equation is true for all values of x? So that means any number we plug in. Well, let's take a look. We have 5x equals 5x. So we have 5 times 2 equals 5 times 2. Well, that's going to work. 5 times 3 equals 5 times 3. Well, that's going to work. Notice that no matter what number you plug in, it's going to be the same on both sides. So all numbers are going to work. So for our answer up here, we have infinitely many solutions. Okay, now take a look at this next one. I know I'm already showing the answer a bit, but it'll be all right. So we have 2x equals negative 4. Well, in order to find this answer, we got to plug in and solve. So look, it's multiplying, so we're going to divide. So we divide by 2 on both sides, and we get x is equal to negative 2. There is no other number in the entire universe that we can plug in for x besides negative 2 that will give us a negative 4. So we have one solution. So this is our little intro to infinitely many solutions, one solution, or no solution. Dun, 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 dun. All right. So now we'll do math and literacy. And we're going to talk about some interesting vocab words. Those are vocab words: equation, no solution, identity, variable, infinitely many, or solution. Okay? So if an equation is true for all values of the variable, then it has infinitely many solutions. Yeah. Okay? If an equation is true, any value that you plug in, it has a solution. So that value is a solution. A mathematical sentence that states two quantities are equal is a equation. An equation that's true for all values of the variable is an identity. And if we have no value that makes it true, we have no solution. And last but certainly not least, a symbol or a letter that represents one or more numbers is a variable. Alrighty. So we were going now to look at the variables. Notice in these equations that the only thing circled are the letters. The 9 is really close to that W, but we do not circle the 9 because the 9 is a coefficient. It's a number being multiplied to our variable. The variable is only the letter that stands for the numbers we don't know. Okay? So this is identify whether each equation has one solution, no solution, or infinitely many. We're going to come back to that once we've learned a little bit more about it. The last thing that we're going to do is talk about an equation. So notice A, B, and D have no equal signs. The only thing different about an expression and an equation is that the equation sign will have an equal sign. Two quantities, 1, 2, that are equal to each other. Alrighty. I bet you guys are ready to jump right into the fun, right? Jumping right into the fun means that we are going to start solving equations. Boom! Example 1, solve an equation with variables on both sides. Well, we have 3x minus 10 plus 4x equals negative 2 times x minus 4 plus 9. Well, we still have the same goal. That's to get x on one side, constants on the other. So the first thing I did was circle my like terms. 3x plus 4x. That's going to give us a 7x, and I bring down my negative 10. Then I distribute it with my arrows to show negative 2x plus 8, making sure I watch my negatives there, plus 9. Notice that plus 9 and plus 8 are, in fact, constants, and they are like terms, so I circle, and I add them together to get 17. Now, the goal is to get x's on one side, constants on the others. I like to get rid of my negatives, so I added 2x on both sides. 7x plus 2x is 9x. And then I brought down my negative 10 and my 17. At this point, it's just a two-step equation, right? So, add 10 on both sides. When we add 10 on both sides, we get 17 plus 10 is 27, so 9x equals 27. Now divide. 9 and 9 on both sides. To get our answer is x equals 3. Now I want to point your attention here to our check. I'm not going to check every single one, but I do want to show you that if you plug in your answer x equals 3 into every place you see an x, then it should come out 11 equals 11, or whatever number is equal to the other number, because it is saying this equation with variables and this equation with variables are the same. Alrighty, let's keep going. So it already gives it away a little bit, but we got that nasty fraction. We can get rid of fractions by multiplying by the denominator. I always like to tell my kids, we hate denominators, so we kick them out. Okay? So we multiply by 2, but notice we multiply 2 by every part of the equation. So we multiply by the 1/2 times n minus 4, the negative 7, the negative 2n, and the 6. So we get 1 times n minus 4 minus 14 minus 4n plus 12. We keep our equal sign. Then I circled my like terms, negative 4 and negative 14. N minus 18 equals negative 4n plus 12. Add 4n on both sides. 5n minus 18 equals 12. Add 18. And last but certainly never least, 5n equals 30. Boom, boom. Divide by 5. And we get x. N is equal to 6, not x. Alrighty. So now we have solved 2 types of problems. The next problem set I'm going to show you are your try it. I'm not going to work these out, but I am going to show them on the screen so that you can see how it is. So what I want you to do is try it on your own and then pause and take a look at the screen and see, did I do it right? Did I get the right answer? Alright, now to keep going, we got example 2. We need to understand infinitely many and no solution problems. We'll take a look at this first one. It's just a normal variable on both sides problem. I go ahead and I rewrite it and then I distribute my 2 like I normally would. I get 4x plus 6 and 4x plus 6. At this moment, if you can realize that it's the exact same on each side and you can realize it's infinitely many solutions, do it. Write infinitely many solutions and be done. But for good measure, it's always good to do it like we usually do. Get our variable on one side, our numbers on the other. When we do that, we subtract 4x on both sides. And notice, we get 6 true statements. Since this is a true statement, it is infinitely many solutions. It's the identity equation. So this is a true statement. That means every value of x you can think of will work. So there you go. Awesome. Okay, are we ready to talk about the next one? I'm sorry if this is hurting your eyes. The next one, just like the last one, is just a normal equation. So we go ahead and we distribute. We get our 6x plus 8 and our 6x minus 5 on one side. Subtract that 6x, because we're trying to get it all by itself, and we end up with negative 5 equals 8. That's false. Negative 5 does not equal 8. So we have no solution, meaning that no x will work in this equation. Okay? And last but certainly not least, I'm not going to go over it too much, but I am going to show it to you. Try it out yourself. Freeze. Solve it like you normally would and see if you get what I get. Alright. Lastly, we're going to go back to what I promised we would. And we are going to talk about this guy here. So notice, if I told you if it is the exact same on each side, you can say it's infinitely many. But negative x and x are not the exact same, so we know it has one solution. Here we have 4x minus 8, and then if we go ahead and we distribute, we get 4x minus 8. Since it's the same on both sides, we get infinitely many solutions. Woo woo. Here we also have to distribute. This is going to be 5, but this is going to be negative 5x, and over here we have a positive 5x. So we know it's one solution. And then last but certainly never least, we go ahead and we have x plus 2x minus 14 with distributing. This gives us 3x minus 7. This gives us 3x minus 14. So what we got to do is make sure that our x's and our 3x's are the same. They're going to cancel out, leaving us with a negative 17 and a negative 14, so we know we have no solution. So in order to have a no solution, the variables have to be the exact same, but the other numbers can't be. Alright. That's all I got for you this time. It's a little bit shorter. I do plan to continue writing in future videos, but this is a redo video to make sure video is good for you to reuse to review stuff and for those learning it. Y'all have a great day. I'll see you in the next video where we talk about word problems.